Hello. So now let us see another concept in this functional dependency, and which is very important, and many places we are going to use. Actually, you can apply in the further discussion. So that is what actually inference rules. So these inference rules, for what purpose we are using them and what we are doing actually. So here if you see, the inference rule is a type of assertion. It can apply to a set of FDs to derive other FDs actually. So we already have some set of FDs actually, some maybe to one or two or some set of FDs are there. By using them and by using these inference rules, you can derive another FDs actually. So that is what it is saying. Using the inference rule, you can derive additional functional dependencies on the initial set. Whatever is basically is given, by using that, you are going to get the new FDs which are valid also. So such a kind of valid FDs, how you are getting? By using these inference rules. So totally 5 inference rules we are going to see. So let us see what are those actually. So the first one is in that reflexive rule. So this is very simple, and we already seen this kind of discussion also. What is that? In this, if y is subset of x, then x is determines y actually. So this we already seen actually, non trivial for FDs. So that is what, if you see y is a superset of x actually, that is nothing but y is subset to y, x actually, y is subset or equal to x, then x is deriving y. So that is what, if you take the example ABC, BC is completely subset to LHS part, okay? Or here you can see title and author, of course title is subset to LHS part, okay? So this is what simple reflexive meaning is, what deriving itself actually. Reflexive meaning is, if you go for the discrete mass concepts, so same thing here you can apply, okay? Then the another inference rule is augmentation rule actually. This is important, in many places we can use it. What is this augmentation rule is? In this, if x determines y, xz determines yz for any z actually. So that you can see, this is already you have. You take any other attribute in the relation, that is z assume. Any other attribute if I take, if you add that in the both the sides, LHS side and RHS side, that is also going to become valid FD. So that is what here it is saying. So for example, you have a relation ABCD. So same example actually, A derives B, and if I add both the sides C actually, here it is B, BC. So if I add both the sides C, then still AC derives BC, that is also valid. Uniquely it will derives, okay? So augmentation rule is also very simple one. Now let us see the next one. So that is transitive rule. So this also you might see in many places, but the meaning is same actually. That is, in this, x determines y and y determines z. So transitively what we can say, x determines z actually, is it? So that is what, x determines y, y determines z. So because both of them is same, so x is determines z actually, is it? So that is what, same thing, same kind of example actually. So transitive rule. So these are the 3 rules. First of all, basically reflexive rule, augmentation rule, transitive rule. These things we are going to apply in many places actually. Try to get a familiarity of this. Now next one, if you see, that is the union rule. This is important. So that you can see in this, if x determines y and x determines z, then x determines yz actually. So how and all you can see. So that is what you can see, x determines y. So that is what you can see here. Let us try to prove this one. X determines y. So this is actually given. And x determines z. This is also given. Then how you will say this one? So by using inference rule 2, what we are going to do is, okay, we are adding here x both the sides for this one, for the first one. So that is what, x. So always x is going to become x only. So x determines xy. Then that you can write down as x determines xy. Okay, fine. And then this part, if you take the second one, for the second one also same thing if you do, but by adding a y both the sides. So X, Y determines Y, Z. Then from this, what you can write down, this is X, Y determines Y, Z. If you observe this part and this part transitively by using inference rule 3, transitive rule, then what you can say, X determines Y, Z. Is it or not? So by using till now, whatever inference rules we used, basing on that only you can tell that this is valid again. Okay. So that is what union. So simply if LHS part is same for different FDs, then RHS part you can combine them actually. That's it. Nothing is there. Okay. And then that is what in the both the LHS part is same, both the sides. Only if same, then you can union the RHS parts actually. Okay. Now if you take another inference rule, last one, so that is decomposition rule. It is just opposite to this part actually. What is that? Let us observe. So in this, X determines YZ, then X determines Y, and then you can write down Y determines Z. Exactly this opposite actually. So that is what X determines YZ, he given. So this is one. Now, can we write like this? Y determines, see, YZ determines Y. Can we write like this? Then transitively from this, this is by using reflexive rule. Is it or not? This part we can write down. And then transitively, if you see from this to what you can write down, X determines Y. So that is what one you proved. And same way, this time you will take Z here. Y determines, YZ determines Z actually. Then from this, what you can write down, X determines Z also, transitively, this part and this part if you consider. So in that way, both the things you are able to derive. So just 4 and 5, union rule and decomposition rule, quite opposite to each other actually. Okay. So individually, that means nothing is there. Every attribute individually you can write down with LHS part. That's it. So by using these inferences rules, if you have a set of attributes, from that you can derive new additional FD section. For that purpose, we have these 5 inference rule important. Okay.